Okay, example 2, Jane's dress shop sold less expensive dresses for $20 each and more expensive dresses for $45 each. The shop took in $1,375 and sold 20 more of the less expensive dresses than the more expensive dresses. How many of each kind did they sell? I should say than instead of that. Typo on my part, sorry about that. I dislike this problem just because the words more and less are just all thrown out. So let's, instead of saying less expensive and more expensive, let's say cheap and expensive. Sold cheap dresses and expensive dresses. Shop took in blah blah blah, sold more of the cheap dresses than the expensive dresses. There we go. Just clarifying things a little bit, making it a little bit easier to understand what's going on here. So we have cheap dresses, expensive dresses. The cheap dresses are $20 each, the expensive ones are $45 each. We know exactly how much they took in, and they sold more of the cheap ones than the expensive ones. All right, so same scenario as before. It's just like a coin problem would happen. We have cheap and expensive. As far as number of dresses, we'll say they sold C cheap ones and E expensive ones. And as far as the value of those dresses, the amount of money made in selling each type, every cheap dress cost $20 and we bought C of them, so 20C is how much money was spent. This is in dollars, right, because that's $20. And every expensive dress cost $45, we bought E of them, so 45E. Represents how much money was spent altogether in dollars on the expensive dresses. And if we take a look at the two facts they give us, fact number 1, they took in $1,375, which means 20C plus 45E is equal to $1,375. Helps to write down the number to say, $1,375. Using the value variables, because that's about value, it's in dollars, this is in dollars, everything matches up, so we don't have to do any kind of conversions or modifications to the numbers. Just like the last problem, 20 and 45 and 1375 all divide by 5 evenly. Not a requirement, but it makes the problem easier to do. I'd recommend it. Let's see, that'd be 2, 37, 9C plus, or sorry, 4C plus 90 is equal to 275. This equation is equivalent to the top equation, easier to work with smaller numbers. The other fact they give us is they sold 20 more cheap dresses than expensive dresses. All right, so if I just put C equals E, that's false, right?
Yeah.
Is C or E bigger?
E. No, C.
C is bigger, right?
Because you have to add.
They sold 20 more cheap dresses, so C is 20 bigger than E. So if C is 20 bigger than E, and I want to make this an equation that's actually true, I take the smaller number, add 20 to make the bigger number. Cheap dresses aren't worth as much as expensive, but we sold more of them, right? So we just piled them up and counted them. The C pile's here, the E pile's here, right? It's a bigger pile of dresses. I don't know if you're supposed to pile dresses. I don't know about dresses. So this time it's set up better for substitution and elimination. C equals E plus 20. I can put E plus 20 in place of that C there. If I do that, I'm replacing a single object C with multiple objects E plus 20, so I use parentheses. And then it's just a matter of solving the equation for E. This is going to be 4E plus 80 plus 90E is equal to 275. I'll move the 80 over to the right to get all the numbers on the right. Adding together the E's, I get 13E on the left. 275 minus 80 is 195. Divide both sides by 13.
15.
Get E equals 15. I'll buy that. So 15 expensive dresses, which means how many cheap dresses? 35.
35.
So 15 expensive, 35 cheap. All right? So the same theory as the coin problems. The only difference is what is the value of the things you're dealing with. And that's what makes it more of a challenge. But again, it works the same way. You want to set up variables as numbers and values. Set up 2 equations based on facts given to you. Use the correct types of variables in each fact in order to create a good system. Solve the system using elimination or substitution.